Hey guys, welcome to a new stream. I was gonna say new video, but that's not correct. I've been video editing for days, so that's probably why. I've heard myself say that a million times now. Let's see if we can get the microphone a little bit closer without disconnecting it. There we go. Hey! So, it's the normal, or the obvious choices, I guess. I'm gonna go with vanilla first. How's everyone's weekend going? Yeah, 15 minutes early. It's almost like I prepared. I actually did. It's because I have a lot of things going on and I needed to finish a lot of stuff so that I'm prepared. So, how's everyone's weekend going so far? I know it's just started, but you know. And what are you guys drinking? Well, there's 26 people here who are joining us for the pre-party. Wow, Gruff Monkey throws in a question immediately. What makes one long-range receiver board different from another, and are they all compatible? And what makes it compatible with each other or not? That's a bit of a too broad question without any details. I'm thinking you're talking about differential receivers, and then it's the type of signal used and the pinout used in the cable and such. But what are we talking about? It doesn't feel like live stream time. It's still bright outside, right? I turned my lights on, and on the camera, nothing changed. You're off at 2200. Damn, Johnny, are you hitting the bars again? Are you making the neighborhood unsafe? Just got word, doing the LEDs for 5 more pedal bikes for a local company here in Ohio. That's awesome, Jeff. Some new Red Bull cactus fruit. Tastes like soap smells. That doesn't sound very good. You may or may not hit some bars. Okay. Sure. Well, it's fun. You're hanging out while you have time, so. Yeah, I'm actually going to be out of town starting tomorrow for a few days. So I had to prepare a video for next week too, and the video went great. Oh, it first didn't, and then it did again. You'll see that in the video. It's a very long video, but I think it's an interesting one. But my video editing software is just... It really let me down. I think I spent about 2 days off and on trying to get it to work, and each time it would take about 3 hours to render, and then after that I found there's a mistake, or not a mistake on my end, but the software made a mistake because it just rendered something different than it was on the timeline. I had to do it all over again. It was horrible, but I managed to squeeze a version out that is acceptable enough, but man. Johnny may or may not end up drunk in a karaoke bar. Oh man. Mr. No Motion says, just lined my new master bed with 530 LEDs with a Dig-Uno. Thanks so much for all the documentation and tutorial. It's working great. Thank you very much for using it, and I'm glad it helped. Could your long receiver board work with a Falcon? I do not have any differential long-range receiver boards yet. I only have the data booster board, and that is not a long-range receiver board. That is basically a rebroadcaster of a single-ended signal, and other vendors' long-range boards generally use a differential signal, which is the type of signal you'd want to use if you're running anything long distance or over an Ethernet cable or something like that. So maybe that answers your question. You're looking at differential receivers, I think, and that's a whole different thing, because then you're transforming the signal from single-ended to differential, and as I said, the pinout and how they do that is going to be important if it's compatible or not. But I'd hope they'd have documentation you can check to see all those things. Yeah, we love seeing results, Mr. No Motion. So, Discord in the showroom channel is always appreciated. Make sure it didn't happen. Do you recommend inline fuses for the Dig-Quad analog? I think you mean the AN quad then? Yes. It should also be in the text there. And in all the guides and stuff like that, that if you run this in any permanent fashion, it's certainly advised to have some fuses on the positive output sides. Good evening, peeps. According to PostNL, a couple of pre-built Dig-Unos will be delivered tomorrow. Yay! Nice. Nice, Edwin's Elf. Well, no, this is a YouTube chat. You can't really post pictures here. Sorry. Hey, Leon Voss is here. Hey there. Oh, I missed one from Ross Costona. Hello from Wisconsin. Going to work on my 4th of July show after stream. Quad boards config into X-Lite and run tests. Nice. Oh, you mean post pics in Discord. Okay, that's good. I'm good. Philip is still waiting for his DIY PCBs. I actually saw on the showroom channel someone received the DIY quad, Dig-Quad V3 already. Nice. So I dug out my my bench power supply today. Ugh, let's see it. Oh, there we go. Oh, the cable is stuck. Ugh, there we go. This guy, still like it a lot. It's just very big to keep on my desk. So I tend to use other stuff. And, well, I also test with lots of amps often. So, yeah. But I still like it. It's cool. It's just too big. So I might, I've seen some other YouTubers do that. Might separate the front from the power supply at some point. But we're going to use that today because it gives a very accurate readout. Something fell. Not sure. It gives a very accurate readout of how much power we're using. What? You have a great picture to share of 2 times 100 square meters of LEDs? That's like, what? My brain cannot even comprehend that. Do you mean 2 times 100 meters or 100 meters square? Because that's a lot. That's I got some good news, says Jocko. I got notified that my PCI Coral TPUs that I ordered on in August 2021 will arrive on Monday. Damn. Okay, well that's a lot of LEDs there, Leon. What source do you usually use for Meanwhile PSUs in the Netherlands? If you'll believe it, AliExpress. But I also have business accounts now. And then Mouser is a good one, because Mouser generally pays for free shipping and the tax. So that's a good one, and then there is a few others that will also sell it to you if you have a business account. So yeah. But AliExpress is pretty competitive too. What wire size should I be using with my Dig-Quad and WS2811 with 300 meters? About 72 feet? What? These numbers. These numbers. I always have to convert 300 feet to meters. That's 91 meters. That's not 300 meters. What? 300 millicentimeters. What? What's going on? I don't know what this means. Mr. Notion says, I had to skip the barrel connector from my power supply and solder the wires directly instead. Doesn't seem like barrel connectors can take that many amps from my experience. Exactly. That's why the Dig-Uno and Dig-Quad don't have barrel connectors, because that would very much limit the amount of amps it could handle. Andreas Tolson is here. Hi Quinn and fellow geeks. Just got a bunch of parts yesterday. Sorry, it's all the Coke. Excited to get started on my first project. Excited to learn a bit about cables and power and how to not burn my house down. Very good. Do I know of a way to have more than 15 presets in WLED? Is that still a limit, Emil Bart? I didn't think so. Oh, 300 LEDs per strip. Okay, that makes more sense. Thanks, Timothy. I have a 72 feet, so that's what's that? What's that in meters? Sorry, I'm a metrics guy. 21 meters. Nice. What size wire to your Dig-Quad? Well, look at the power sheets on the website. And there you can see how much amps it uses. And generally I like to use the 50% figure. So, but I know WS2812B's 300 LEDs use a max of 13 amps. So let's say 7 amps per roll. And if you're using 4 rolls, that is 7, 14, 28 amps. So that's a lot. So make sure to have at least like 2 times 12 gauge or something going to the Dig-Quad, to make sure you don't get too much voltage drop there, and then that will be your distribution point to all the smaller cables, so that's fine. You're early again! Yeah, I like to have a little bit of a pre-show so we can, you know, hang out, have a talk. I don't know either, Emil. I've never made that many. I have size 42 shoes, so how long are 32 feet? Right? I have no idea. I remember when Dr. Z's was building his Hobbit hole, a Hobbit hole, he was like talking to construction people, and he's like, yeah, I need 16 1/5 2 seconds of an inch. And it's just a stupid measurement. I need 32 centimeters, thank you. Leon Voss, I built those advertising screens near the highway, like the Brienenoordbrug. Oh, okay, cool. 3 times 100 meters square. Damn. But those are giant LEDs, right? They're not like high density screens, are they, Leon? Emil just looked it up. 250 presets. That should be enough. Do you have a tutorial for beginners? Or do you have a tutorial for beginners? Do you have a tutorial for beginners? Do you have? That's a lot of the same question there, BB. There is all kinds of articles in the digitally addressable LED section on the website. You can scroll down a bit. Or otherwise in the video archive. But I'll post one link real quick, which is, you know, it has some getting started stuff in there with WLED. So check out the videos that are in this article. That'll likely help you get along. Timothy says, thanks so much. Now I have a fun hobby because of your videos. No problem. Separate RGB LEDs. Okay. Cool. So, it's time. Oh god, BB loves me. That's a bit much, man. But, okay. Glad you're happy. So, today, what we're going to do is we're first off going to take one of these standard rolls, and this is the bodged one with all the wooden crap in it. We used a little bit before too. And we're going to measure the power that it uses once you just turn it on with a single injection, and it's 5 volt WS2812B 60 LEDs per meter, so 300 of them. So, and then we're going to do some measurements using certain values, kind of like the power sheet does. And then we're going to chop off the cables. No. Then we're going to add those little extra cables, see if that makes a difference. Then we're going to chop off the connector, see if that makes a difference. And then we're going to change the wires, see if that makes a difference. And, well, in the end, I also hope to have some clips that'll explain to people why they need to power inject and can't just, you know, solder thicker wires to the strip and solve the problem that way. Because, you know, that doesn't work. So, yeah. That's what we're going to do today, and maybe later on we'll take a look at some SK6812, because I have my load testing bars and I used SK6812 RGBW for those on purpose because they can draw a lot more power. And I also have another strip here, which I believe is also just normal WS2812B, which already has a middle injection wire attached, so we can see how much power that will draw. And, you know, we're just going to do some fun experiments here. And then we will take Philip on the bed and solder 1.5 square meter cable to the strip. Wow. That's going to be interesting. Oh, Philip will only do that for Johnny, not for me. Oh well. Yes, that's correct, Mr. No Motion. If you only use the WLED, which is much better white light anyway. It's not great white light, but it's certainly better than RGB white. That actually uses less power than RGB white. So that's certainly true. Absolutely. That's the right way to do it, too. So, yeah. Winner takes 10 pink LEDs. Nice. Well, again, while we're talking about it, we have kind of a purplish pink background right now. It'll auto cycle, but you know. So let's prepare that a little bit, because we need to make some measurements here. Why is this so choppy? Oh, no, it is actually correct. Okay, that's fine. What's this? Oh, okay. So let's first hook up the board, and we're going to try and use the bench power supply. But I'm actually not fully certain about my connection I have here. We're going to see about that. But, yeah. Let's hook it up and just see. 10 watt LEDs. Damn. The bet is for 10 pink LEDs. If he wants them, he has to do it himself. Okay, sure. I'm not going to help. So let's wire in some power. I really like these new connectors. They're good. How do you set the minimum brightness in ESP Home? Analog LED. You can set a minimum value in the code, I believe. You'd have to look up an example on the ESP Home website. I don't know from head either. Okay, let's get this cable somewhat twisted. There we go. So, I think we need to program this ESP first. I've shown you guys that a gazillion times now, so I'm not going to do that while sharing the screen. I'm just going to go to install.wled.me. And I want to, I want to install, thank you, let's go. So 1.5 millimeters square. What size is that in AWG? Because I actually use wire gauge more often to describe cables. It's the only cable standard that I kind of understand, because it's easy to describe a certain cable. Instead of saying 1.75 millimeters square or 1.83 millimeters square, that actually kind of makes sense to me. But yeah. Is the music too loud? I don't know. Is it too loud? I can just, you know, turn it down. There we go. And maybe I should turn myself up a little bit. There! How's that? Ah, okay. I'd have to look into that, Ibrahim. I haven't used that too much myself. Okay, well, I fixed the music. But we have a little bit of YouTube lag, so... We're at 76% of programming. I'm interested to see what's going to happen, how much power we're going to be able to use. Okay, let's connect it to my Wi-Fi. Connect. Yes, okay, and it's connected. Good. No, we don't need this anymore. Let's wire up some cables. I have my little box here of LED leads because I use them often. So I already have pre-ferruled ones. Okay, let's screw that in. Where is my magic auto screwy? Let's use LED channel 1. For those who haven't seen yet, this is the... it's kind of dark, isn't it? Where do I do that? No, yes, but no. There we go. These are the V3.1 of the QuinLED-Dig-Quad boards. So they now have the onboard resistor switchers, which can be useful if you're running 3-wire cables and such. So that less data booster boards and things like that are necessary now. Yep, this is red. Good. So we have ground data into LED 1 and then positive. Good. And okay, let's put on the ESP. Make sure it lines up. There we go. And let's first test without anything connected to the board and see how that does. So let me turn on my socket. And let's go power supply, booting. I'm not going to be able to show you the screen all too well. I'll have to lift it up to do that, but that's okay. So let's try and do that. I guess you can see it a little bit. It's not great. Anyway, let's turn it. Oh no, that idiot. Sorry, that's the wrong button. Let's. I've set it to 5.1 volts and 1 amp. Okay, let's set it to 5 volts exactly. I haven't used this thing too long. Okay, 5 volts. Let's go. Bam. Okay, board is on, and it's currently drawing 0.17 amps. That's not a lot. Okay, I need to figure out a better solution for this. I actually have one, I think. Wait. Hold on, I need to rearrange some stuff. Let's turn this all off. going to rearrange the desk a little bit. Oh, there we go. Yeah. This will work. This will work. One moment, please. It's okay. It's okay. Okay. Where's the camera? Let's get this cord here. Hold on just more seconds. Almost there. Almost there. There we go. Turn that on. And I thought I was prepared today. I guess not well enough, eh? Okay. And now we should be able to go here and hit this guy. No? Maybe it needs to be this guy. No, it shouldn't be. Are we not functioning? One moment please while we deal with technical issues. Oh, there we go. It's this guy. No. There we go. And now if I turn it on. Yes! Yes! I don't know how long the battery will last. Why are you wearing a headset? What are you listening to? I listen to the music myself because I actually enjoy the music, and that way it doesn't disturb the microphone and the screen and stuff like, or the stream and stuff like that. So let's see if we can focus that a little bit better. Perfect. Hey, so now let's turn it on again. Okay, and the board boots a little bit and goes into Wi-Fi mode, and then it's drawing 0.17 amps it seems. So let me see what... Oh, wait. I updated my router and now I can't look at the IP. Hold on. Because I need a newer version of their management software. But that luckily is done very quickly. And now I can look at the IP. Wondering food. Yes, okay. Wow, and when I refresh the page, you can actually see the amps jump a little bit. And I should be able to make that more detailed. Not enough. Okay. Anyway, I just wanted to see what the board was going to use just by itself. So nothing is connected to it. And, well, we can actually do that right now. Let's connect these LEDs. And that immediately raised the utilization. Oh, we need to write this stuff down, don't we? Right. So, board without anything, 0.17 amps. And then board with 300 LEDs is 0.5 amps. Okay, let's keep a little document here. I'll share it on the screen later, and I likely will make a post about it. Okay, so now we have a base measurement for what the board uses, 0.17 amps at 5 volt, and we have a base measurement what the LEDs use while not being turned on. Okay. So, okay, I'll share my my screen too. Hold on just a second for that. Oh no, this battery died. Oh. So much unpreparedness. Okay, let's fix that. Nope, other way around. We'll get to the measurements soon, guys. Sorry about that. Um, 150 milliamps. It's just the ESP, and the DC circuit itself isn't 100% efficient. You know, there's a little. Oh, this is not the right battery at all. There's a little LED on there, and yeah. And we're back. Okay. I was starting to share my screen. There we go. So now you can at least see something. Okay, so in WLED, let's go to the LED configuration, because that's not currently set. Let's disable the brightness limiter for now. We're not going to use that today. And we have 300 LEDs on pin 16. Save. Bam. Okay, I need to set something differently, because it was set to limit to 1 amp output. Let's make that 5 amps. Okay. And with that, we can now see that we're drawing 2.11 amps. So, where's my document now? I'm so not here. Okay, board with 300 LEDs, WLED default is 2.1 amps, right? And I want to check something real quick, because I'm not really sure about how well this cable is behaving. Yeah, the board uses about 1 watt idle. That's about correct. No. I need to change the batteries on my multimeter, I'm afraid, because it's not behaving exactly like it should. So let's see what voltage we see on the input terminals currently. 4.85. Yeah, I was afraid of that. This cable that I have on the power supply just isn't the greatest. That's kind of a problem, I guess. I might have a solution for that. So let's forget this number for now. The other numbers are correct, but now we're just seeing voltage drop, and there shouldn't be any voltage drop yet. Well, yeah, that's one of the things we're going to look at today. John John Curran. And indeed, those aren't ideal, the DSD connectors. So let me get this cable. I think I should be able to put that into the terminals here. With a bit of finessing. Because I don't want to see drop from the power supply to the board. That's not really useful for anything. Not in tight enough. I know you can't see. I'll show you in a minute. Okay, so I changed the wiring setup to some bigger 10 gauge cable now. So let's hook that up over here. And hopefully that eliminates the voltage drop we just saw while it was not really doing anything major yet. Okay, this cable, oh no, I pulled it out again. Hold on. Should actually reverse this one. Nope. Should work. Okay, that should be better. I'll fix the screen in a minute. There. And let's see, screen should still be readable, I hope. Yeah, that's okay enough. Right? Okay, let's do that again. Okay, and now let's measure voltage drop. And perfect. So now, while the board is on, we still get an exact 5 volt on the input terminals, so we don't have any voltage drop on the input wires to the board anymore. And we can already see that made a slight difference, because before we were drawing 2.10 amps and now we're drawing 2.16 amps because, well, there's a higher voltage, so that allows more power to be drawn. Okay. So, well, that fixed the problem over here. Let me try and get some stuff on the screen here. There. Right. So, let's define our test parameters. What we're going to test with. Currently, we're testing with 50% orange. And that is that 2.16 amps. And let's also test with 50% red. 50% red. That is 1.94 amps. And then test with, well, 100% red. 100% red is 2.73 amps. And let's go back to orange. 100% orange is 3.03 amps. And now let's go to 100% white. And remember, we have the brightness limiter off. And 100% white or RGB white I should write, RGB white is 4.26 amps. But something that isn't very visible right now, I think I can change that. There, is that if you look at the LED strip, you'll see that the middle is a lot brighter than the end, and the end has become some kind of yellowish orange. You can't really see that because we're experiencing massive voltage drop, you know, because the LED strip isn't getting enough power. Okay. Let's turn that down a little bit because otherwise we're going to burn through it. Now I turn power down and you can see it's a nice and even white. Let's go back on the camera. Okay. So, the first test I want to do, and well, the first thing I want to do actually is unspool this LED strip because we're going to, oh right. I can't unspool this LED strip because the glue layer, well, maybe I can anyway. Well, we're going to do it anyway. But this LED strip has the tape removed because I glued it down somewhere before. That's why we're testing with it. Oh, it's actually coming off the spool pretty good. Even that little 100% white there warmed it up quite well. So that actually helps with removing it from the spool. That's nice. Because the next test we're going to do is we're going to, next to having the GST connector there, we're going to connect those extra little wires there and see if that makes a difference in power draw for those same scenarios. So then we can see if we were actually having a lot of voltage drop. Tech Turtle is here. Or not. Okay, so we don't need this anymore. So let's take this side and, well, there we go. This should still be used the same, so if we put this to 100%, yeah, 4.15, and I noted down 4.26. That's fair enough. That could actually be the difference here. And yeah, if I squish the connector a little bit, it actually goes from 4.15 to 4.41. And if I let it go or pull it apart slightly, it actually influences how many amps are being used. But that doesn't matter for right now. We have our value for 100% white and the other ones, orange and red. So now what we're going to do is we're going to attach these little wires as an extra and see if that makes a difference. Temperature influence, of course, because they're warmer now. That's true. So we can already see that these wires are quite thin. And I'm not even going to use ferrules right now because I'm going to snip this off later anyway. Be a waste of ferrules. Where is my screwdriver? No, we're trying to see if the JST is actually limiting, and then if the cables are actually limiting if we replace those with a thicker variant. And we're basically proving why you need to voltage inject. And you can't just use bigger cables onto one side or something like that. Now I'm skipping one of the screw in places because, or screw terminals. Let's try and get that in there. Because that uses the same fuse and I wanted to use a different fuse, so I'm using this one. Okay. Extra wires are in. Let's turn on the power. Good, and it starts immediately at 50% orange. So I'm going to take my document real quick. JST plus extra 2 wires, 50% orange, is now 2.28 amps instead of 2.16 amps. So it's using a little bit more. Let's go to 50% red. And that is now using 2.28 amps. That's using a lot more because before it used 1.94 amps. So let's go to 100% red. Let's do that. No, wait. It didn't go to red. My bad. Confirm. Didn't do it right. No, I made a boo-boo. I need to do 100% red, because I did that wrongly. That is using 2.01. And now I need to look at 100% red. That is using 2.9, I'll say. And now we're going for 100% orange. Just so we have comparable values, right? That is now using 3.25 amps. Before it only used 3 amps. Oh, my power supply decided to make noise. That's another fact I don't like about this thing. Might improve that at some point. So now let's go to 100% white. And that is now drawing 4.8 amps versus the 4.26 amps it did before. So attaching those little wires there made it so that it can use slightly more power than it was able to before. Tech Turtle says, my SD cape is taking forever to arrive. It's not your fault, it's just killing me. I want to play. Well, they should be there soon. I mean... I guess we should raise the limit for the amps too. Let's go, let's say it's allowed to use 10 amp. There we go. Or 11 amp, that's fine too. Didn't change the readout, so that's fine. So, even with the extra cable connected, we can't go above 4.75 amps. And even if we do, well, it's hard to show on camera, but we're having massive voltage drop here. I mean, let's do, for fun, let's do a little measurement. Let's take our multimeter again. And let's measure what we have at the other side of the strip. Almost. I have to pin it down with the measurement leads. There we go. At the other side of the strip, we're only seeing 2.5 volt. That's way too low, and that's why the LEDs are discoloring and stuff like that. And for instance, if we go to orange and 50%, we're seeing 3.5 volts. That's still 1.5 volt of drop. So even orange 50% is dropping massive voltage. Okay, but we're going to do this by measuring the amps. But what we've basically now proven that with this normal setup, whatever I do, I can't really get more than 4 amps into the strip effectively, right? So let's talk about voltage injection a little bit. So even with these extra wires connected, I can't get more than 4 amps to basically go into the strip. Now let's get the connector for the other side and see what happens when we connect that one. I think I have one with ferrules on there. Yep. So keep an eye on the power being used. Currently we're using about 2 amps. And we're set to 50%-ish white or orange. There we go. Okay, so again, we're doing about 206 amps. But we just measured that over here at the end of the strip, we're only seeing 3.5 volts. So let's see what happens when I connect the other side to the controller too. It got a little bit brighter, and now we're using 2.36 amps. That's because this side is now also getting a decent 5 volt, and thus the average voltage over the strip has now increased. And if we now go to 100%, this is now using 4.75 amps, while before with only the JST connector, 100% orange only used 3 amps, and 100% orange with the 2 extra wires used 3.25 amps. But now, let's see, JST plus extra 2 wires plus JST on back side of strip, 100% orange, 4.74 amps, right? And now, yeah, less voltage drop means more current, more power, and more light. About what you would expect. That's right, Guido, but a lot of people don't necessarily know this by instinct or by nature. They think, I just need thicker wires to go to, you know, this spot on the cable, because then more power will reach it. But the problem is the copper inside of the strip. So now let's go to 100% white. And now we can see that we're using about white 8.22 amps, where before the 100% white was only 4.8 amps. So that's why I generally, when doing calculations and stuff like that, I have a golden rule, as you might say, that a single injection on a strip will only allow you to inject about 4 amps on a side or an edge injection, as I call them, or about 8 amps or so if it's a middle injection, because then power can flow both ways, because, you know, it has more copper close to it. But you can see here, we started with 4.26 amps, and now we're at 8.22 amps just by adding this back connection. Because if I remove it, we're down to 4.74 and having all kinds of massive voltage drop and stuff like that. And if I now add it back, well, you can see the difference in power usage. Let's up that graph a little bit. There. What? Inductors? The 5 volt feed to the 5 volt pin, that might just work. If we're talking a QuinLED-Dig board, don't do that. Because that is an output pin, not an input pin. Oh, you fried your board? Oh no. Well, let me turn this down a little bit and let me read what happened, because, you know. It worked when I hooked it up with micro USB cable. Okay. Sorry about the noise from that power supply, it's annoying. I'm gonna replace that at some point with a passive 48 volt or something. Oh, not a QuinWar. Okay. I was confused. Well, actually, on the ESP, you're allowed to feed it using the V-in pin. So, yeah, with 5 volt. Anyway, so... conclusion time. Power injection is a real thing. Even on a 5 meter 5 volt strip, you can see we can use almost double the power if we inject it on both sides. But the question of the video was that if we replace these cables, will that make a difference? So we're gonna not use this second injection here, right? Because, you know, and the first thing we'll do is we'll snip off this connector and wire in the bare wires to see if that gives us a better input voltage or less voltage drop than, you know, than not doing so. So let's remove this. Because, okay, we just proved that injecting power on the other side certainly helps. Let's remove this. Because we looked at adding these little 2 wires. That seemed to help a little bit. Let's snip those off before they short circuit. There we go. And now we're going to snip off this part. Let's say, you know, snip it off pretty closely there. There we go. Okay, let's remove this. Because we're just going to wire that up directly without the GST connector and stuff like that in there. Where's my wire strippers? No, don't worry about hijacking. The chat is open for all kinds of things. Sometimes people get bored when I'm doing anyway. Let's see. This is the green wire. Yeah. And then we need a red wire. Because, I mean, I get what people are saying. These wires are really thin. So, maybe that's causing the limit in power we can get to the strip. Instead of having to do a second injection. Who knows? Well, we kind of know, but it's still fun to look at. So let's do positive first. Okay. And then let's do negative. That's okay. Oh. Okay, and now let's do the data wire, because we need data too. There we go. Okay, so that's now all wired up directly without the GST connector, because, you know, that's over here. So let's see what that does. And maybe that makes a difference. Maybe it doesn't make a difference at all. And later we're going to remove those wires and solder on the thickest wire we can. Oh, Johnny's heading out. Later, Johnny. Okay, let's see where we're at. So, just front with snipped off JST connector. 50% orange gives us 2.27 amps. That's already a little bit more. It's about the same as it was with the 2 wires connected, and instead of just having the JST connection. Let's do 50% red. That is now, 2.00 amps. Okay, that's about the same. Then we go to 100% red. There we go. That is now 2.88 amps. Before, with the JST connector, that was 2.73 amps. It's a little bit different. So let's go to orange. That is now 3.23 amps, let's say. Before, with just the JST connector, that was 3 amps. And now let's go to 100% white. And that is now 4.75. And with the JST connector, that was 4.26. So that actually gets a little bit more power into the strip, wiring it up directly without the GST connector. But it's still not that much, and we're getting massive voltage drop, and yeah. Is it possible to share your measurements in a Google Doc to watch the results in real time? I'm not that familiar with Google Docs, so Not right now, but I'll look into that in a future episode. But I can, I think, share my window. No, not that one. No, I can't. I can't share my window. What? Hold on. Oh, there we go. How about I do this? I make it larger, but then I chop off the top part. Oh wait, why is the chat not here? Is the chat not here? Sorry, seems I have disabled the chat. Oh no, this stream is such a horrible mess sometimes. There we go. Okay, I'll just move this over here a little bit. Oh. Okay, okay. Let's remove the 100% white here too. So now we can see the dock a little bit, right? Let's zoom it in. I have to make it proper. There we go. So snipping off the JST connector actually did help a little bit, because now 100% white is 4.75 amps, while before it was 4.26 amps. So, and likely having these shorter cables help too, but yeah. So, now let's do what we said in the video description. Let's take off these original wires. Let's solder on the thickest wires we can get on there and see if that makes a difference in the amount of power the strip is going to take. Right? I borked it? No, it's okay. Yeah, that's right, Henrik. The wires are shorter, so it you know. Okay, let's see how I'm going to do this. Orange wasn't set to 50%. Yeah, it was. Let me reboot it, because that automatically makes it 50% orange. Yeah, we were at 2.27 amps, and we're now at 2.2526. So that's about correct. One can is finished. Okay, let me get my soldering iron. If I can. It's kind of a wiring mess here right now. Let's get some solder wire. I'm going to use the leaded one, because, you know, slider glitch. Ah, okay, that's possible, yeah. Oh, hey, Dustin. Didn't see you there. Okay. Let's turn this all off. And well, we need to fix it anyway. So let's unscrew this. Ah, the slider wasn't there. Okay, sure. Well, it's a good catch. I'm not infallible either, so... Okay, let's get a surface to solder on. And the easy thing is, we can just stick this down, because it's sticky anyway. Let's get a little bit more of this. Nope, that's too much. Still too much. Let's zoom in. We'll do a little bit of a how to wire LED strip stuff. There we go. So, arrow is important, otherwise data is not going to work. Let's remove some of the screens here. There. Okay, let's get this off first. Onderzetten! Oh yeah. It's always the best surface to solder on. Right? Okay. So we have 5 volt positive, data in, and ground. And now you can also see that the 2 red wires and the 2 white wires are just soldered to the same pad, and then you have the data wire. So that kind of already tells us that if we're going to replace this with one larger size wire and that one too, it's not going to make that big of a difference because these 2 wires together likely already had the same diameter as one big wire. But yeah. I don't have any recommendations for that right now, Miguel. There's lots of stuff on AliExpress that's pretty decent generally, so let me get some decent sized wire. What's this? Okay, so this is 16 gauge. Let's see if we can bodge some. Okay, and this is good for data wire. No. The 16 gauge is going to be a challenge of itself because I mean, look at that wire size. That is quite a bit more than that's on there right now. Oh wow, they actually soldered it and then epoxied it in. That's quite neat. I'm gonna wear my glasses for this. No, I don't. Yeah, 18 gauge is generally what we recommend because that is already tight enough. So this is going to be a real challenge. But I'm going to use a little trick. And the trick is I'm going to solder the data wire on the bottom side and then the power wires on the top side. So let me try and get this epoxy off, if that's even possible, because the cables are in there too. I'm trying to get this off without destroying the strip. No, okay, I'm ripping the strip anyway. Okay, I'm not gonna bother. Sorry. Where is my scissors? I'm gonna do it the easy way, and I'm going to snip off one LED. There. So now I have a clean surface to which I should be able to easily remove that epoxy like that. There we go. I'm gonna try and... Nah, I'm not gonna try and preserve the epoxy. I'm not gonna use this strip for anything anyway. There we go. Okay. Okay, so now we... Yeah, I know, we now have one LED less. Well, I think we'll manage. Okay. So let's determine the length of the cable we're going to use. What the hell's going on? I want cables that are this long. Yeah, I'm too zoomed in. I'll show it over here. Cables that are this long. It's not that long. I see I need to adjust my camera because now the sun is gone. Let me do that real quick. There we go. Now I'm actually, visible. So let's do that the same length. Yeah, but the old cables are really short, so I'm gonna make them this long. I mean, with this thickness cable, it's not gonna matter too much anyway. And sometimes, if you have to retry, you have to snip a part off. So, okay. I mean, generally, I think when people are going to do this, they're going to use longer cables, actually. So now, to strip the wire, you only want a tiny little piece here, like that. So, not a lot of wire at all. I know, but this isn't a scientific lab test. This is a test to see how much current you can get into the LED strip from one side. So, in that regard, this is shorter than the standard cables plus JST. This is about the same size as the standard cables without the JST connector. But, you know, and we also have one LED less. Well, we'll see a little bit of smoke during soldering. So what I'm going to try is getting this 16 gauge onto the pads here, and then I'll put the data on the pad on the bottom. Yeah, this is just a approximate test to see what it does, right? The strip itself is 5 meters with 60 LEDs per meter. So it was 300 LEDs. It is now 299 LEDs. And if we don't bork it up, if we do bork it up, it's going to be even less. Let me turn this on. Okay, so the first thing we'll do is turn on my soldering iron, actually. This tip might be a bit much. We can try. So the first thing we want to do is we want to tin the pads so that it takes on the solder, like that. So you put your iron on there, you flow some solder in there, you move it around a little bit. There we go, that's it. Done. The second thing we want to do is tin the wires we're going to connect to those pads. So we're going to hold the iron on there and just flow a bit of tin into the wire like that. Moving off screen here. No. Pre-soldered cable. No. We're making this all ourselves. So same over here. We're going to heat up the cable and flow some solder into there to pre-tin the wire. Okay. And I'm gonna get something to hold it down with because it can get hot. Let's try and line it up a little bit. Like so. And then I want something I can hold it down with, like so. And then I'm going to melt those two together. And I really want to hold it down. There we go. That should make a decent connection. And we're going to do the same with the second wire. And we're just going to flow it into the pad. And because both sides have solder, they kind of just want to join together. Okay. So let's take a little look at that. I mean, it looks stupid because the wire is way too big. Okay, so this one's kind of far off the board, or off the LED strip. So I'm going to hit that again while pushing it down. Let me clean the tip real quick. There we go. The point is to see if it'll take in more current from a single connection or not. Okay, so that is at least not touching the data pin. And we just successfully soldered 16 gauge, and I don't know the European equivalent for that right now, to an LED strip. And the little trick we're going to use is that I'm going to peel back the sticky tape layer. Which is all dirty because we use the strip. Okay, there, got it. So, there you see we also have pads on the back, which is great. And I need to hold this down somehow, so let's do it like that. Because now we can solder the data signal to the pad on the back. 1.2 line millimeter, right. Thank you. Millimeter square, I think that, but yeah, thank you, Dustin. So, let's do pre-tin that. There we go. And let's take our data wire and pre-tin that. Doesn't need a lot because it's a really thin wire. Okay. And, well, the idea is exactly the same. And we'll put some heat shrink over it so it can't touch, or we can just peel back or put back the sticky layer. Because the sticky layer also forms the insulation layer when you're sticking it down in an aluminium profile or something like that. Okay, so that is almost touching. That's good, because now we just need to hit it very softly. And the idea is, because both sides are tinned, they join together really easily. So that is on there. Good. Now let's try and put back this sticky layer, because, you know, why not? I don't know. As best as it goes, it's not perfect, but is it on the inside or on the outside? Well, it doesn't matter because we're going to put heat shrink over it anyway. Okay. So let's move this out of the way right now. Put this back. And I need to get some heat shrink. Hold on. It was actually over here. Good. So yeah, heat shrink, and I like to use clear heat shrink nowadays, because then I don't have a problem going over the first LED, because oh, it's clear, so you can still see it, and we can easily slide that over the cables. Because this will reduce, I believe, 3 to 1. So even though it's kind of big, especially if you squish it like that, it should be fine. And I'm just going to take my hot air station and not set to 300, but set to, like, I don't know, 200? 196? Fine. Ooh, yep. Let's wait for that a little bit more. So I'm just going to point the hot air station at the heat shrink. And there you go. Oh, wait. And there you go. Now it's neatly heat shrunk, and I believe there's actually glue in there, so it's sealed into the epoxy a little bit. And there's glue here too, so although I'm not sure this will be perfectly weather tight, it should be pretty good. And even though this pad is slightly exposed, because the heat shrink is now on there, it shouldn't be able to make an electrical connection anymore, so that's perfect too. Last thing to do is to finish the wires on the other side, and we want to do this the right way, so we're going to snip this off and put some nice ferrules on there. Let's take the mega crimper out. This is a new one, but it's doing very well. I like it a lot. And let's get some ferrules. We need one little tiny ferrule. And we need 2 of the yellow ones. Oh, wait. Maybe we need 2 of the black ones, actually. There we go. Because this is 16 gauge. I normally use 18 gauge. So, but you know, this is to prove a point. Evening Quinder from the UK. Hello there. So we put the ferrule on the cable. And then we crimp it. I should just turn this off because it's making a lot of irritating noise. There we go. One crimped cable. That should be on there. Yep. I think we need to use the black ones because this is 16 gauge. Let's see here. Yeah, this is a perfect fit. There we go. Should have crimped these or cut these slightly longer, but it'll be okay. There we go. Because normally what you kind of want to see is the cable poking out almost or slightly on the exit side, but it's okay enough for now. And okay, let's get the board back. There we go. Oh, other way around. And wire that up. Let's zoom out a little bit. So, data. Data is like a 24 or 26 gauge. It's very thin. Doesn't really matter. Now we might need to deploy a little trick here, because these ferrules might actually be slightly too big to go into the cable sockets or the terminals here. Yeah, that's difficult to go in. So what we do, we take a plier or something like that, and we just put the ferrule in there and we squish it flat. So then that goes in just fine. There we go. That is 16 gauge with ferrule on a production board. No problem whatsoever. Okay, let's put the ESP back on. There we go. Well, now, let's take a little break. What are our predictions? Are we going to see massively increased power usage? Is it going to be about the same? My prediction is that it's going to be about the same as the JST plus the individual wires we tested with. And not that much more. But then again, there is a lot more copper. I mean, this even looks stupid like this. It's just, that's a big wire there. So let's see what that does. Or it's not going to do anything and I botched it all up and it's going to burn and die because the soldering was crap. Same 6.5 amps, okay. You were able to put 13 gauge on there? Holy shit. Maybe if you stagger the pads or something like that, but 2.2 amp higher, 10-15%. Is that an option? Burn then. Yes, who knows? Maybe I just bodged it all up. You know, you saw me do it. Maybe it's just not going to do anything and burn. I don't know. I think it will increase, but not a lot. Okay, sure. Fire extinguisher. Yeah. Don't worry. I've got my my can of fire stop. No, other way around. Can of fire stop is right here. It's like next to my desk nowadays, because, you know, you've seen these streams. You know what happens. Okay. Same result, no difference. Okay, let me put my, that expired long ago? No. What? Let's see here. There's spider webs on it. That's not a good sign. Oh, it actually doesn't say. It says, date of production, 05-2016. But it doesn't say when it expires, though. It's not on the bottom either. Nope, doesn't say. Don't know. It's indefinitely well. It holds forever. No problem. Okay. Are we ready to see what it does? Let's add some LED strip here. There we go. And maybe we can get a nice glow. Did anyone see BitLooney's glowing diodes? That was funny. Okay. Maybe I should add this one? No. This one? Yeah, sure. Okay, let's turn on the camera. Okay, and let's focus that. Okay, let's boot up the power supply. Ow. Almost 6 years old, yeah. Yeah, he really burned his finger. That was, yeah. It was good YouTube, but that must have hurt. Okay. Are we ready? We're set to 11 amp max, so it can potentially draw up to 11 amps. It won't though. Ah! At least the soldering was a success. At least grant me that. Okay? Okay. So, strip with replaced 16 AWD power cables only. 50% orange is using 2.30 amps. Okay, that is the most so far, I think. Let's go to red. 50% red is drawing 2.02 amps. That's about the same as we had before. Now let's go to 100% red. Okay, 100% red is drawing 2.92 amps. Okay, that's more than the snipped off version at least. Okay, let's go to 100% orange. There we go. 3.28 amps. A little bit more than we had before. White. Here's the kicker. 100% white. 4.86 amps. Save. Okay, so looking at the document, no, let's lower this brightness before we burn up the strip. No, don't do that. Okay, I want this document. So we started out with 50% orange was 2.16. That is now 2.30. 50% red was 1.94. That's now 2.02. And then we had 100% red was 2.73. That is now 2.92. A little bit more. And then we had 100% orange at 3.03. That's now 3.28. A little bit more. And 100% RGB white was 4.26. And this is now 4.86. So more is getting into the strip. But let's do our voltage measurement test we did too. To see what has changed in the voltage at the end of the strip. So let's go back to 100%. I mean, I know you can't really see. Can you see the difference in that? Hold on, let me remove this. This is the start of the strip. This is the end of the strip. And there are actually LEDs here. It's just that much dimmer. Okay. Multimeter time. Yep, okay. Somewhere over there. No, don't do that. What's going on? Okay. So, coming in to the board is 4.977. So, the voltage that's coming into the board is basically 5 volts. So, the input cables on the board almost have 0 drop. Then let's look at the front of the fuse, 4.971. At the end of the fuse, you can't really see there, that's 486. So the fuse is always dropping a little bit. We can actually try and replacing that fuse because we're almost at 5 amps, but we're at 4.853 volts at the terminal. And then let's measure what the end of the strip basically is measuring. You can't see, but no, stay down. It's hard to do this. 2.5, that's about the same as we measured before, which is logical because the strip is still causing massive voltage drop, so the end value isn't really going to change by inputting or getting a little bit of more power into the front. Yeah, that is the whole story, Philip, but I just wanted to physically basically show that this is happening and that attaching much bigger cables to your LED strip than you had before basically isn't going to solve the problem of voltage drop, and that adding the same thin cables but to the back of the LED strip immediately solves the issue. Even more, 1 LED less. That's true. That's true. Now what did I want to show again? I don't remember. I guess we can attach the other side again. No, that's not this wire, is it? I forgot where I put the other side JST connector. Should be here somewhere. It's not here. Nope. Oh, here it is. So let's wire this extra side in again and see what that does. Oh, actually, well, I'll wire it in, but then let's replace the fuse from a 5 amp to a 10 amp and see maybe if the fuse was limiting us the whole time. Who knows? Right, let's turn this off. Let's take this fuse out. There we go. And I should have something here on my desk. Something like this. What's this? 15 amps. Sounds good. There we go. So, although we wired this in, it's not connected yet. Here we go. Let's turn that on. I'll take the WLED off the screen. Okay. We're doing 2.28, so changing the fuse there didn't make a difference at all. Because that was 2.3 before. But let's go to 100% white immediately. And that is doing 4.88. And according to our... Before it was 4.86. So that is basically the same, 4.87. And now you also know why there is 5 amp fuses on the Dig-Quad and not 10 amp or 15 amp. Because whatever you try and do, a single edge injection will basically only give you 4, well maybe 5 amps, but that's 5 amps with massive voltage drop. So effectively it'll only give you 4 amps of power that you can get into your LED strip. That's why there's 5 amp fuses on there. And I get that question a lot, but I wanted to show you in a video why that is. Maybe Quinn can touch on the heating of strips at high brightness. Yeah, this is heating up right now because, well, there's an red, green, and blue diode in there, and running RGB white makes them turn on all at the same time, and there's also no pattern running on there right now. It's just solid, so they'll heat up a lot. So if you'd ever want to run it like this, it will definitely have to go into an aluminium profile, or you're going to kill the LEDs pretty quickly. But looking at, I mean, yeah, you can't really see the power difference now because it's not properly injected. But just going to red makes it so that it's using, each LED is using 1/3 of the power. So that means there's also being only 1/3 of the heat generated for that particular LED, and thus a lot less heat, you know, needs to be carried away. And that's why I sometimes say, okay, you know, addressable LED strip, especially if you set it on a pattern like this, it doesn't really need to be cooled because only a single diode is lighting up. It's not at 100% the whole time, and a pattern is lighting things on and off the whole time. So, I mean, you can even see it. The current is only 1.4 amps right now, so that also means that there's only 6 or 7 watts going into the strip, and thus there'll be a whole lot less heat than if you say, no, but I'm doing solid white, which suddenly means there is now 24 watts going into the strip, which is also being converted to heat. So, yeah, if you want to run anything 100% on all the time, especially if it's RGB white, don't do that. Get RGBW or something else. You'll want to have some cooling on that strip. Basically, the more the power goes up, the more heat will be generated, and the more cooling or an aluminium profile or something like that will be necessary. So yeah. You know what comes next? Soldering fat wires on the end as well. But why would we do that, Endelich? Because we just proved that the fat wires don't do anything. I mean, it's within 1 to 2% of the thin wires. So why would we then do that? And, I mean, it's also going to depend on how you use your strip. For instance, with this current effect, we're drawing about 1.35, 1.4 amps. And if I now connect the backside, it doesn't really change. Because, well, the voltage drop wasn't too bad because only a few LEDs were on. It's only when a lot of LEDs are going to be turned on, so more power is being used, that it's actually going to make a considerable difference. Because now we're at 2.4 amps or so, and if I disconnect this, we're now more around 2 amps. So here, even with this effect, there was already enough voltage drop that you needed a second injection. So, yeah. Fade. Yeah, that's going to be white. Ah. So let's see what 2 injections now do. 8.33. And well, from this you can also see why I say that a single injection, you calculate with about max of 4 amps you can get into the strip. Because realistically, well, you're seeing it right now, you're not going to get too much more than that. Maybe on 12 volt, which can accept a little bit more voltage drop, you could stretch that to 5 amps or something like that. But to calculate with, I just generally use 4 amps because amps are amps. It doesn't matter what voltage it is. But then with 12 volt, you have a little bit of more voltage to drop before the effect has the same visible difference. So, yeah, that is basically the whole clue. You don't need to replace the wires on your LED strip. You need more copper alongside your LED strip to inject in another place to make sure that there's enough current that can flow everywhere without too much resistance and thus keep the voltage as it should be. So yeah, hope that makes sense. It's fun. You can see the little pattern here on the load for when the pattern of the LEDs fluctuate. So let's set it to, I don't know, this guy. Oh, okay, this is a pretty constant 4 amp. And if we disconnect the backside, see, even just with one 5 meter strip set to the Paletti effect with 100%, it does about 3 amps with just the big thick front leads. And if we then connect the backside, I can visibly see a clear difference in the strip, and now it's drawing 4 amps, and now it's no longer limited basically because we have a front and back injection, which basically for most scenarios for 5 volt is fine. But I mean, for something like, I don't know, for this effect, it's likely not going to make that much of a difference. It's a little bit lower, but maybe by 10 or 20, 0.10 or 0.20, I mean, yeah, it's not much. So yeah, it really depends. Do you need it? I'd say yeah, but it depends on your situation and what effects you're going to run, and if you're okay with seeing voltage drop and stuff like that. It's okay at oneself, but it really depends on what LEDs you have connected, and then you need to fill in well, the power that those are going to use. You can use the real world power sheet for that if you want to. Just use the 100% white value and then divide it by 300 generally, and then divide it by the voltage, so you have the milliamps per LED, and then you can put in a custom milliamp value. And then it's fairly okay, but it's just a guesstimate, basically. Yeah. Sure, Ross, Costona, you can use a parallel bus wire with thick copper cable, like, I don't know, 10 gauge or something like that. But make sure, if you really want to do it properly, make sure you have a fuse on each injection wire that goes to the strip. Oh, okay, sure, we can do that. So, let's put WLED back on the screen. There we go. So I have to enable the brightness limiter for that, but let's set it to 80,000. It's 80 amps. That should be fine. This pattern is really cool. It's interesting. Anyway, let's see what it says right now. It says we need estimated current, not calculate. Okay, I guess I need to set it lower. Oh. It didn't say. Oh, okay. It has a maximum value. There we go. Okay. Right. It says it currently needs 3.5 amps. And we're doing the front and back here. So the back is also connected. So there's, well, I'm not going to say no limit, but there's very little limit right now. And it's using 1.7, 1.6. And WLED says it's using 2.1, about 2.1, while in reality we're doing 1.6. 2.3, 2.6. Yeah, but we're only doing 2. Yeah, a Dig-Uno, realistically, you shouldn't want to push more than 15 amps through there. 10 to 15, because the voltage drop, if the cables you can use will get a bit too much, then that's what the Dig-Quad is for. That can handle a lot more current. Yeah, but Ross Costona, if you're running a big bus wire, so like a 10 gauge, that 10 gauge might be able to handle 20, 30 amps or something like that. That's fine. But then you connect a tiny cable to that to branch off to your LED strip, and that cable might only be able to handle 5 amps or 6 amps or something like that. So going from a thick cable to a thin cable, you need a fuse in between, because otherwise you might burn up that thin cable if a short happens or something like that. So if you want to be perfectly safe, each injection wire needs a fuse separately. Or if you have a bus bar, you fuse the bus bar wire at 30 amps or whatever, and then each injection wire gets its own fuse also. So that's a lot of fuses, and that's why I like doing it this way, because then each injection wire gets its own fuse, and you can calculate the fuse and change it, whatever. So yeah. So 2.5 here, 3.7 there. So yeah, I'd say WLED estimates it slightly too high. Now I think that's because the default is 5 volt 55 milliamps, but let me calculate something real quick. Oh, let me open the webpage real quick. Hold on. All right. So let's go to the digitally addressable LEDs, and then go to the digitally LED power usage sheet, and then open the 5 volt sheet, and here we see that 300 LEDs perfectly injected will use about 65 watts. So let's do some math. 65 watts times divided by 300 is 0.21 watts per LED. Divided by 5 is 0.043. So 43 milliamps instead of 55 that WLED is using. So let's say custom. And let's say, no, I think my LEDs use 43 milliamps instead of 55. Save. And now let's see what it does. It says 1.7. Sure. 1.9. Okay, yeah, we're at 2 right now. Still a bit too high. 2.7. 3.1. Yeah, it's still estimating too high, although we set the LED current to lower. Sure, no problem, Swiftly. But yeah, but that's what the Dig-Quad is for. That's why it has 5 fuses. So you can have all kinds of injection wires coming off there directly, and those will always be fused. That's also what I do in my Christmas tree. I have 3 strands connected to the first fuse, 3 strands connected to the second fuse, and 3 strands connected to the third fuse. So then if anything happens there and that draws more power than I expect, the fuse will pop and everything will be safe. So yeah, let's set, I don't know, let's set it to solid. Oh, it's now saying we need 13 amps. Yeah, that's kind of overestimated there. Let's go to 100% red. 4.7. Okay, so that's still way too high. So let's make it 35. I think that's actually in here. 5 volt efficient is 35 milliamps. So let's select that. Maybe that is a bit closer to reality. that's perfect actually. It's saying 3.9, and a WLED is also saying 3.9. Let's go to a double color. So orange, 4.75. Need to adjust the graph a little bit. There we go. 4.8. Oh, that's okay. That's pretty close. That's only, you know, yeah, that's fine. Let's go to white. 11, 8 point. Okay, so white isn't accurate, but all the others were pretty good. 7.4, 6.5. Let's do an effect here. 1.3. Sure, that's pretty close. It's maybe a little bit too low, because the actual usage is slightly higher. Color twinkles, or color waves, that's a nice one. Okay, 2.1. Sure, it's 2.2. Dig-Uno doesn't support up to 25 amps. No, and you also won't be able to get a thick enough cable in there to be able to use those amps, because that's basically what we're talking about. The whole of today is that you need a massive amount of copper to be able to handle a certain amount of current, and you can only get about 16 gauge or something like that into a Dig-Uno, so you're limited to what a 16 gauge cable can effectively handle. Even though you can double up at the end of it, you can't really double up at the beginning of it. So 10 to 15 amps for a Dig-Uno, and if you need more, go to a Dig-Quad, which can easily handle up to 30 amps, you know, using these beefy input terminals, 10 gauge cables and stuff like that. And then having two 10 gauge cables coming in, you can easily have 7 16 gauge cables coming out, and then the board will do the power distribution and fusing, and that way you have a perfect setup that's attuned to each other basically. It's just calculated, Jordy, it's not measured, so you kind of just need to fill in the number that corresponds best to your LEDs. Right now we're seeing it's slightly too low, so 35. Let's say we're so for these LEDs I'm using, I guess it's about 37 or something like that. Sure, yeah, that's about in line. But it's just a guesstimate. Yeah, I've dabbled with the idea, but generally it'd just be a wasted circuit, because not a lot of people are going to look at it like, okay, I calculate this effect to use that much power, but it's only using this much power, so where is the problem? Well, generally it means you do not have enough injection points, but not a lot of people get that idea behind that. Ah, that's a good thing there, because maybe you want to read this article. Where is it? 24 volt buck converter, 24 volt distribution for 5 volt LEDs. It's a whole article about using buck converters with LED strip and how you can do that. So, got you covered there, Tema. Although on BitLooney's stream, we've been noticing there's an issue there. If you don't have enough resistance or other circuits in place, that can actually damage your LEDs, but running it through a Dig-Quad should make that pretty safe. Can the QuinLED run both 12 volt and 5 volt strings at the same time? Sure. If you input 12 volt and then put a buck converter on the output to make it 5 volt, it can do that. Or if you input 5 or 12 volt, one of those, and then have the other. So let's say you input 5 volt and you have another 12 volt power supply. You connect the 12 volt strip to that power supply and the 5 volt strip to the Dig-Quad, and you share a ground. There's an article for that, says Philip. Thanks, Philip. But you share a ground, then you can also do that, but then you'd have to do the power distribution and fusing yourself. A single board only supports a single power supply. You can do all kinds of things beyond that, but a single board will always only support a single power supply. So, yeah. Can I run RGB and gRGB at the same time? Yes. On two separate data ports, that's no problem. I don't think you can do that in one continuous LED strip. New subject. When will you start new project with 2 ESP32? 2 ESP32? Why would I need 2? What? I see we're approaching the 2-hour mark, so we're gonna start rounding this off a little bit. Rounding this off a little bit. That is the best Dutch English ever. We're going to start ending this. In Dutch we say afronden. It's literally mean you're gonna try and curve it off. But rounding this off is very badly translated Dutch to English. Teaser time. I don't have a teaser prepared. Sorry about that. I guess I could do something. Maybe I can share an old version of this. Oh, hold on. That's heavy. Okay. Oh no. Okay. Maybe I can do an old version of this. Huh. I guess so. So I'm gonna hide it. So pay close attention. It's only going to be in the screen for like a second or so. This is to be combined with the teaser of the last stream. So here's my desktop. Oh, I need to zoom out. Nope. So here's my desktop, and here is a little teaser that can be combined with the previous teaser. So there it is, and it's gone. And we're not going to talk about it. We're going to talk about it soon, in a few weeks. So this combines with what you saw last week, or a few weeks back. Yeah, you can sync multiple boards. That's not. There's multiple options to do that now. Abdul Aziz Fahad. Yeah, this is a true teaser because I've been working on this stuff since November, so it's slowly starting to be shown. Please take a look at the new Lian Li Unifan SL Infinity. I think you will love them. Maybe show the YouTube video. You know, it could be a cool fan. I don't know. I don't have RGB fans in my computer because I prioritize cooling above anything else. So my build is fully Noctua, actually. Maybe EarthGamer XE. Maybe it's 60 amps. I don't know. .2 gigawatts. Yes. Unlimited power. Are you part of the WLED programmer? Not sure what that means, but I do not program on WLED myself, no. Oh, another teaser then. Next week is going to be a video, and in that video, I say it in the video too, but there's going to be some stuff that can be used with what I just showed you. Yes. Thanks, Swiftly. Oh, later, Dave Odessa. We're going to end the stream now anyway, so yeah. thank you all for watching. As I said, next week will be a video. Maybe the week after that we'll do a live stream again, not sure. This is just thanks. Thank you, Savag. I'm going to try. Savag Barsumian. Hope that's okay. Thank you. Too much teasers. Well, you guys want teasers all the time. Come on. Anyway, thank you all for watching. I hope to see you back on the Discord server in the next live stream. Maybe in a video, leaving comments, likes, subscriptions, everything. You know, maybe there's an article or a video for someone else who is struggling with their first LED setup, etc. Maybe send them along one of my videos or articles or stuff like that. That's always greatly appreciated. And I'm now going to stop begging. So, see you guys next time. Bye-bye.